All right, so I quickly want to talk about the concept of a Taylor expansion. All right. We're going to use these a lot as we derive our equations. So the concept of a Taylor expansion is really simple. And it's essentially something you would know to think about it this way. The idea of a Taylor expansion is to say this. I have some sort of function. It looks like this, okay? And I might know the value here, all right, at what we'll say is x0. All right, so at x0, I know f of x0, right? This is my function, f of x, all right? And I want to know the value at some distance away here that we can either call dx or delta x. Let's call it dx, because that'll work later. But I don't know my function very well. But I happen to know that I know dx. Let's say I know, so over here at this position, x0 plus dx, I don't know what f of x is, or I'd like to estimate f of x. All right, I'd like to estimate the value here. All right, so the way we can do that is through something called a Taylor expansion, which is essentially assuming a straight line, all right? And so what we would say is that the value of a function at f of x plus dx, or fx0 in this case, all right, is equal to the value of that function at f of x0 plus the derivative at x0. I'm going to write partial derivatives just because that makes sense later, times dx, right? So if you think about this, this is really y equals mx plus b, right? We're saying that I don't know what the function is, but I can estimate its value at some distance dx down by taking the derivative in the value of the function, all right? And this is something we're going to use a lot moving forward as we develop some of these equations, so I thought I'd do a quick lecture on it.